Let's go back to this. All right, so we are in fact recording. We are here with A4 Precalculus CP right after lunch period, the last period of the day on a blue day. Again, just a couple of reminders. If you would like to participate and ask a question, please feel free to interrupt at any time. You can just unmute yourself and ask, or you can type in the chat if you don't want to do that. Make sure your webcams are deactivated, and if you haven't done so, please sign in for attendance. We are recording now, so let's go ahead and get started with some precalculus. Today, what I would like to do with you guys is I'd really like to just review the trig graph stuff that we've been talking about. I posted the review on Classroom, which was supposed to be a test review. It is not going to end up being a test review because the test is going to be pushed back. I'll talk about that a lot more at the end of class versus now at the beginning. But what I still would like to do is get everybody back up to speed by doing one of each style of problem. One problem where you're given the equation of a trig graph and you have to draw it. One problem where you're looking at a graph and you have to come up with the equation, and another word problem, just so you see an example of one of each of the three. All right, I'll talk a lot more about the structure of the class going forward after all of that stuff. So let's go ahead and get started. Again, if you do have a question at any point, please feel free to just interrupt and unmute yourself and ask, or you can just type it in the chat. I'll be able to see that as well, but hopefully everybody can see my presentation, so let's do it. On that trig graphs review, the problem that I'd like to show off to you is problem number 2 to get started. Because problem number 2, I think, is a great graph that kind of encompasses everything we've talked about. We have y minus 3 is equal to 2 sine of 1/2 times x minus pi over 2. And again, this is number 2 on the trig graphs review that I sent out earlier. So what you want to do if you want to sketch a graph of this function is you want to identify first the characteristics of it. Those characteristics being the axis of the wave, the amplitude, the period, the phase shift. So you could do them in any order that you like. I like to start with the axis of the wave because I think it gives you a good reference point to go with. That axis of the wave is going to be y equals 3 because it's just the opposite of that number. It's whatever value for y would make the right side of the graph equal to 0, just FYI. Next we have the amplitude. The amplitude of the graph is this number right out in front here. That's 2 units in this particular case. And what that means is the vertical center of your graph will be at y equals 3. At its highest, the graph will go up to y equals 5, and at its lowest, it'll go down to y equals 1. So it'll oscillate 2 units in either direction. We also have what's called the phase shift. The phase shift is essentially like your horizontal shift when you're graphing other types of functions. Here, you notice you see this minus pi over 2 over there. So that just means that instead of starting at x coordinate 0, which most of these trig graphs usually do, we're going to be starting at x coordinate pi over 2. So that just shifts it positive pi over 2 to the right. Remember, the phase shift, just like horizontal shifts with other types of graphs, is the opposite. And last but not least, we have the period. We remember that to find the period, by the way, the period means it's the amount of time that the graph takes to complete a cycle. And to find the period, you may remember that we do 2 pi over the absolute value of b. Well, in our equation, this value is what's referred to as b. So I can say this is 2 pi divided by 1/2 should be the period. Again, to divide by a fraction, we don't freak out and panic. We just multiply by the reciprocal. It's 2 pi times 2 over 1, which is 4 pi. So that means after starting at pi over 2, it's going to take 4 pi units for the graph to get through a whole complete cycle. So that means if we're starting at pi over 2 and the period is 4 pi, that means from pi over 2, we're going to advance 4 pi units in order to complete the graph. So the graph is going to end at, well, we could probably rewrite 4 pi a little bit better. So we can say this is pi over 2 plus 8 pi over 2. Now that we have a common denominator, you can combine those and see that the graph is going to end at 9 pi over 2. So we're going to start at pi over 2. We're going to advance 4 pi units because that's how long it takes to complete one cycle. And we're going to end at 9 pi over 2. To go ahead and sketch a graph now that we have all our information. Notice I'm going to leave a lot of room up top because you see that the axis of the wave, and everything's pretty much in that positive quadrant anyway, so I'm not going to leave a lot of room down at the bottom so I don't waste a lot of space. The lowest we go is 1, the axis of the wave is 3, the highest we go is 5. We can go ahead and draw in our axis of the wave, just like that. Our starting position, we already stated, is pi over 2. Again, the scaling on the x-axis is not particularly important. What is important is that you label your coordinates. So that's what provides that scale. You label your values. I'm starting at pi over 2. I'm ending at 9 pi over 2. This is a sine graph. We know that sine starts on the axis of the wave, goes up like this, back to the axis of the wave, down like this, and back to the axis of the wave. So that's the exact picture that we're going to model. Keep in mind that if this were cosine, we would start at the top, go down to the axis, down to the bottom, back to the axis, back to the top. If this were negative sine, we would start on the axis, go down first, then back, then up, and then back. And if this were negative cosine, we would start at the minimum, go to the axis, go to the maximum, go to the axis, go to the minimum. So really just the shape of your graph is dependent upon the actual function, but other than that, it doesn't really, the process is still the same, whether it's sine, cosine, negative cosine. So since it's sine, we're going to start right on that axis of the wave. We're going to end right on that axis of the wave. Halfway between, we are also going to be on the axis of the wave because that's how sine looks. Now, what's halfway between pi over 2 and 9 pi over 2? That's going to be 5 pi over 2. You can think of that using the unit circle and say, well, what's going to be, you could actually trace it out and say what's going to be halfway between. You could also think of it in terms of just fractions, like you have 1 pi over 2 and you have 9 pi over 2. And even if you remove the pi's, you have 1 half and 9 halves. What's exactly between 1 half and 9 halves is 5 halves, right? 4 units away from here, 4 units away from here. So there's a lot of different ways to approach that. If you actually just want to do it mathematically, you could actually just add them up and divide by 2 to find the midpoint. So you could do pi over 2 plus 9 pi over 2 is 10 pi over 2, and then cut that in half, you get 5 pi over 2. So there's a lot of different ways to go about that. Now that I have that, I know halfway between there and halfway between there and there are also critical points. Since this is sine, you know we're going to be up at the maximum, halfway between pi over 2 and 5 pi over 2. And at the minimum, halfway between 5 pi over 2 and 9 pi over 2. Halfway between pi over 2 and 5 pi over 2 is 3 pi over 2. And we're not there. Up at the top. And halfway between 5 pi over 2 and 9 pi over 2 is 7 pi over 2. And so now I can just go ahead and make my lovely sine graph, which looks like that. Very good. Ignore that little marking there. Does that make sense to everybody? Hopefully it does. Again, if you have any question at all, just feel free to interrupt or ask via the chat, which is great. Okay? So hopefully that all makes sense. So that's a typical trig graph that we've talked about in the past that you should be able to do at this point. And again, whether it's sine, cosine, negative cosine, that graphing process of finding the attributes, sketching the graph, finding these midpoints is all the same. The only thing that changes is your shape of the graph. If it's cosine, you're going to start here, go down and up. If it's negative sine, you're going to do this. And if it's negative cosine, you're going to start here, go up, and come back down. So that's really all there is to that. All right, excellent. So now what I'd like to do is I'd like to show you an example of a graph, or of drawing, given the picture of a graph, can you go ahead and create the equation? That's really what I want to show you now. I think a great example of that is problem number 6 on the trig graph review. So that's the one I want to do with you. Again, if you have that open in another tab, problem number 6 looks like this. It's also an easy one to draw, which is convenient for me. So if I have, problem number 6 gives me something that looks kind of like this. We have a point at 1, 0. We have a point at 3, 1. And we have a point at 5, 0. And we're pretty much just given this little section of the graph that looks like this. And another little bit over there. And so we're asked to come up with an equation that can model each graph. What I'm going to do for you is I'm actually going to do it from those 3 different points. So regardless of whether you're working with sine, cosine, negative cosine, it's all about finding those attributes. So we need to first find the Oh, by the way, just a little quick reminder. The general form of these types of things is y minus k equals a sine or cosine of b times x minus h. So we're really just trying to fill in all of that information so we can come up with an equation. We can start by finding the axis of the wave. If you notice here, the axis of the wave is actually the x-axis. It's just at 0 is exactly the center of this wave because it only goes up at its maximum point to 1 and it continues down to -1. So your axis of the wave here is y equals 0. It's the x-axis. From there, we can then find the amplitude. Remember that the amplitude is the distance from the axis of the wave to either the maximum or the minimum. The amplitude of this graph, it looks like it would be 1 unit because it goes up 1 and down 1 to its highest and lowest points from the axis of the wave. We also have the period. That's another thing that's not going to change regardless of your starting point. Now, the period of this graph is a little tricky. If you notice, remember, the period is the amount of time it takes the graph to complete a full cycle. If you notice, this graph really only provides us with half of a cycle. It tells us the distance to go from the axis of the wave up to the maximum, back to the axis of the wave is 4 units. But that's not a full cycle. That's not what the period is all about. The period is really twice that. The period is how much time does it take to go all the way to the end of your cycle. And Jacob, I'll address your question in just a moment. How much time does it take to go all the way to the end of the cycle? It takes 4 units to go here. It's going to take another 4 units to get all the way to the end because this is really only halfway. So you can observe from that the period shouldn't just be 4, the period should be 8 because it would take 4 additional units. So since your period is 8, you can say, well, 2 pi over the absolute value of b should equal 8. Right? So we can just do a little bit of algebra to solve for what we would actually get. You can say that, well, 2 pi should equal 8b. Divide both sides by 8, you would get 2 pi over 8 or pi over 4 for this value of, oops, just went off the page a little bit, for b. Okay? Hopefully that makes sense to everybody. So that information is all true regardless as to where we're starting on this curve. Now, if I call this point A, and I call this point B, and I call this point C, we can actually come up with different equations for the different starting points of this graph, depending on what we're doing. If I want to start at point A, well, your amplitude's going to be the same, your axis of the wave is going to be the same, the period's going to be the same, but what's going to change is the phase shift. That's not going to be the same. Because now we're starting at the point 1, 0. So your phase shift is +1 because we're starting at that x coordinate of 1. Again, it works just like the horizontal shift. Your function, since we are starting on the axis of the wave, we go up to the maximum, back to the axis of the wave. That's exactly what sine does. We saw that up there. So I would say that my function is the sine of x. And so my equation, therefore, just using my general form from over here, I would say it's y minus 0. Again, you don't have to write the -0. I'm just doing it for consistency's sake. You would just put whatever the axis of the wave happens to be right there. Equals, your amplitude is 1. You, again, do not have to write 1. I'll just do it for consistency. 1 times the sine of pi over 4 times x minus 1, just like that. Hopefully everybody sees that, yes? And now we can go ahead and continue to find other matching equations for the same wave, but just starting at different points. If we're now starting at this point B right here, I can say that my phase shift is no longer 1. My phase shift is now going to be 3. And my function is no longer sine because we're not starting on the axis of the wave now. If I start here, notice we're starting at a maximum. So if we're starting at a maximum, your function is going to be cosine because that's exactly what the cosine function does. And last but most certainly not least, you would go ahead and create your equation by saying it's y minus 0 equals your amplitude again is 1 cosine of b, which is pi over 4, times x minus 3. Hopefully that makes sense to everybody. And we're going to do just one more where we now have point C. If I were creating an equation from there, Your phase shift, again, amplitude, axis of the wave, period, all the same. Your phase shift is now positive 5. Your amplitude, sorry, not your amplitude, your function would now be negative sine. And your actual equation would now be y minus 0 still equals, your amplitude is now negative 1 sine of pi over 4 times x minus 5. Good. I went right to the bottom of the page there, but hopefully that makes sense to everybody. Jacob had a great question when relating to graphs. He said, I still find setting up the y-axis to be confusing. How do I know how much space to leave in the positive and negative areas? When you're actually drawing a graph, I think that's a great question. When you're drawing a graph, it's all about your axis of the wave and your amplitude. The fact that your axis of the wave is 3 and your amplitude is 2 units means that you're going to be centered around 3. And at the highest, you're only going to go up to 5, and the lowest, you're going to go down to 1. So you should create your graph in such a way that it's going to highlight this amount of space. You know that since the lowest you're going to go is 1, you don't need to extend way down here in the negative space because you're not going to ever go down there. The highest you're going to go is 5. You don't need to go way up like that. It's just your graph's going to exist between y equals 1 and y equals 5. So that's how you can help set up your y-axis. Hopefully that's a helpful explanation. All right, cool. Now that we did one creating a graph, we did one looking at a graph and creating the equation, I'd like to end on doing a word problem with you. So let's gear up to do that. Again, if anybody has any questions, just feel free to go ahead and chime in and just say so. All right. Moving to a word problem. I would, again, on that pre-calc review, like to do word problem number 9. I think 9 is a great problem. It really exemplifies all of this trig stuff very, very well. Now, looking at a problem like number 9, I was initially very put off by this problem. I was like, are you kidding me? If I'm reading this problem, which maybe you can do in another tab, it is on Classroom. It says, high tide in Narragansett Bay today was 2.5 feet at 3:06 a.m. and low tide was 0.5 feet 6 hours and 24 minutes later. And we have to find an equation that models the function. So I would look at that and I was like, really? 3:06 a.m.? Like, can we not just say 3 a.m.? But actually that 06 is a very convenient decimal and one that we can definitely work with. It's definitely not outside of our capabilities. However, you should know that for any trig problem, any word problem anyway, what we have to do is always, we're looking for those 5 pieces of information 100% of the time. Before you even read the problem and dive in, you know that we need to find, just like we did before, we need to find the axis of the wave. We know that we need to find the amplitude. We know that we need to find the period. We know that we need to find the phase shift. And we know that we need to find the function. Now, you can choose to find these in any order, and different word problems will lend themselves to a different ordering in which you find this information. But let's read and try to dissect this. Another key piece of advice that I want to give you is whenever you're working with time, it makes a lot of sense to set time equals 0 to correspond with midnight. Since that's the start of a new day, and even in the problem, if you notice, it says in part A, find an equation that models the depth of the tide as a function of time since midnight. That just helps keep your problems organized so you're not working with ugly decimals. Like if you set time equals 0 to be 3:06 a.m., well then it's going to get really confusing and really hard to keep track of your scale. But if t equals 0 is midnight, then that would mean that your 3:06 a.m., which corresponds with high tide, by the way, could be represented by the decimal 3 point. Now, you know, because 3 is 3 full hours since midnight. But 6 minutes seems like initially kind of annoying. But the fact that 6 minutes have passed, well, an hour is 60 minutes, and 6 minutes would be 1/10 of an hour. So I can represent that using the decimal of 3.1, because 3.1 hours have passed since midnight. That 0.1 again comes from 6 minutes, which 6 minutes out of 60 minutes in a whole hour, that's 1/10 of an hour. So that's how you get 3.1. It then says that low tide occurred at, it was 0.5 feet, and it was 6 hours and 24 minutes later. So low tide being 6 hours and 24 minutes later, let's see if my math is correct, from 3:06 a.m., that would mean we went to 9:30 a.m. And you could represent that using the decimal. That's an easy one. You could say that t is 9.5 in that case, right? Because that would be 9.5 hours since midnight. So hopefully that makes a little bit of sense. Now that I'm going from there, let's actually try to find our information. I see that the high tide is at 2.5 feet and the low tide is at 0.5 feet. So that's your max and min. I think it makes a lot of sense to try to find the axis of the wave, because the axis of the wave is right between that max and min. What's the value that's exactly halfway between 2.5 and 0.5? Well, that's 1.5. So your axis of the wave is going to be y equals 1.5. Your amplitude, well, from 1.5, how high does it need to go to get to 2.5? How low does it need to go to get to 0.5? Your amplitude is 1 unit. Because, again, that's the distance from your axis of the wave to the top and axis of the wave to the bottom. Let's see. What else can we find? The phase shift, well, we're starting at 3:06 a.m., which we represent as 3.1, so that's positive 3.1. Since we're starting at high tide, that means we're starting at a maximum. If we're starting at a maximum, then that means our function is cosine, because we'd start at the top, go to the axis, go to the bottom, go to the axis, go to the top. Okay, fantastic. Last but not least, we have the period to deal with. So remember, the period is the amount of time that it takes the graph to complete a full cycle. Here, we're given the amount of time that it takes the graph to go from high tide to low tide. And that amount of time, let's see, what actually is that amount of time? So from high tide to low tide, oh, it says it right here. It's 6 hours and 24 minutes, right? You can represent that with a decimal of, let's see, from 3.1 to 9.5, that's going to be 6.4, correct? But that doesn't represent the entire cycle. The entire cycle is when you start at high tide, go to low tide, and come back to high tide. And that's the key. So if it takes 6.4 to complete half of the cycle, then a full cycle, if my mental math is correct, would be 12.8 hours. Hopefully that makes sense to everybody. All right, again, if you have a question, feel free to chime in. So we got our axis of the wave, we have our amplitude, we now have our period, which we can find because we know 2 pi over the absolute value of b should equal 12.8. And just doing a little bit of algebra, we can see that 2 pi should equal 12.8b if you multiply both sides by b, divide both sides by 12.8, and we're going to end up with what looks to be a kind of a messy value, but we really don't need to use that value very much other than just putting it in our equation. We're going to end up with 2 pi over 12.8, which we can reduce to pi over 6.4, and that's equal to b. Again, a messy looking value, but not a value that's going to hugely impact my graph. It's just the value that I need to put in the equation to create this wave. Speaking of the equation, let's go ahead and see what that's going to look like right now. Again, if you have any questions, please feel free to ask. But looking at my equation now, again, we want to fill in all of the information from the general form. The general form here is going to be y minus k equals a cosine of b times x minus h, just like that. So now we have all of that information. We can just go ahead and fill that in and then sketch a graph. So my k, my axis of the wave, is 1.5. So I have y minus 1.5 equals my amplitude of 1. Again, you don't really need to write the 1. I'm just doing it for consistency. Times the cosine of b, which is this ugly value here. It's pi over 6.4 times x minus h. Well, h is 3.1, so I'm going to say x minus 3.1. And so that's your equation. Again, hopefully that makes sense to everybody. Now to actually sketch a graph of that, it's not as tricky as you might think. In order to come up with a little bit of a better scale for the graph, I am going to, actually I'll do it down here. I am going to label the y-axis each as 0.5 units, just so it looks a little clearer. So we're going to make this 0.5, 1, 1.5, 2, 2.5, and 3. Just so it looks, just so the graph's not all squished together. On their x-axis, you know that we're starting at 3.1, right about there, and we're ending at, actually, where are we ending? Did we figure out where we're ending? Not yet. We can find out where we're ending, though, because you know if you're starting at 3.1 and you're ending 12.8 hours later, well, you would continue the length of your period, which is 12.8 hours later. And if my mental math is correct, we would be ending now at 15.9 hours later, correct? So we're going to end here. We'll just call this 15.9. And again, the scaling of your x-axis is not what's particularly important. What is important is that you label those points. So if you notice, you can if you want to, but I didn't count out 15 boxes. Just the fact that I labeled these as such, that's enough to show my information that I need to deliver. So in any case, we're going to have my axis of the wave right here. I have my, let's see, I know the highest I'm going to go is 2.5. The lowest I'm going to go is 0.5. Since this is a cosine graph, I'm going to start at the maximum. I'm going to end at the maximum. Halfway between 3.1 and 15.9, since it's cosine, we know that we're going to be at the minimum. Well, what's halfway between 3.1 and 15.9? I don't know. We can figure it out, though, because we can say, well, 3.1 plus 15.9, and then just divide by 2 to find what's exactly halfway. 3.1 plus 15.9 is going to be 19 divided by 2, which is 9.5. And hey, look at that. We were actually given that 9.5 hours would be the halfway point, because it says from high tide to low tide is 9.5. So that should all match up, and that should all be consistent. So we can see that 9.5 show up right there. Now, since again it's cosine, we know halfway between 3.1 and 9.5, we're going to be on the axis of the wave. And halfway between 9.5 and 15.9, we are once again going to be on the axis of the wave. So what's halfway between 3.1 and 9.5? Again, we could just use a little bit of algebra to help us figure that out. 3.1 plus 9.5, it's just a little bit of a midpoint to kind of find the average. That's going to be, let's see, that is 12.6 divided by 2, so what, 6.3? Halfway between 3.1 and 9.5 is 6.3. I hope I did that correctly. And then halfway between, and if not, just feel free to correct me, halfway between 9.5 and 15.9. So we got 15.9 plus 9.5. We can divide by 2. Oh boy, mental math. This is going to be 25.4 over 2, which is, let's see, that's 12.7, I believe. So that's going to be right between 9.5 and 15.9. Cool. So now we have our graph of cosine just looking like that, which is fantastic. Hopefully you noticed that even though this problem involved using some decimals and it wasn't as clean of values as we saw with the previous example, the process is still the same. I extracted all of my information from the word problem. I was able to build my function once I extracted that information. I could then draw my graph by establishing the axis of the wave, establishing the starting point, advancing by that many units to get the period, and then just cutting in half to find that, cut these in half to find this, cut these in half to find this. So hopefully that makes a whole lot of sense to everybody. If anybody has a question, again, please feel free to ask, but we only have about 1 minute to go, so that was a pretty well-timed lesson, if I do say so myself. A couple things I want to say to everybody. So with the general structure of this class going forward, we were instructed not to administer any summative assessments over this little 2-week virtual learning time. If it does extend beyond 2 weeks, which I have no information to confirm or deny that, then we will have to talk about summatives. So as of now, there will not be a summative assessment on the trig graphs currently. There will be one eventually. It is something that you will be held accountable for in the future, but just as of right now, there will not be a summative on the trig graphs. Next class, what we're actually going to be doing is Mr. Danzer and I decided to teach you something called the Law of Sines and the Law of Cosines. Now, that sounds like a really scary thing, but really it's just a way to find missing sides and angles of a triangle, or the areas of a triangle if you don't know them. we picked that topic because it's something that we do in the class anyway. It's a little out of order, but it's something that we think would be easier for you to wrestle with and grapple with on your own, since this is largely independent time, versus something like trig identities, which is what we would normally do next. That's a really kind of thing that really helps when it's more guided with the teacher involved. So that's why we chose the law of sines and cosines. So starting next class, that is what we are going to do. What I'm going to ask for next class is I'm not going to have an official assignment for next class, but I am going to ask that if you were struggling with the trig graph stuff coming into today, that's fine, but hopefully today really tried to clarify everything. And if you're still struggling, please practice up one problem from each section, and that should really help you get to where you need to be. All right, so that's what we're looking at. If anybody has any question, please feel free to ask. Again, not going to have you officially submit anything for next class, but again, if you feel a little iffy on the trig graphs, it would be to your benefit to go back and try another problem from each section again. Starting next class, though, we are going to have consistent homework assignments going forward. All right. Nick asked if he can go to the bathroom. I'm surprised Ryan hasn't asked yet. Sorry, call out. In any case, any other questions or concerns? If not, I hope you have a fantastic rest of your day. Thank you for being so cooperative and understanding and fantastic today. That's all I got for you. All right, that's all I got. I'm going to end the recording now. And I think that was a pretty successful first pre-calc period, huh? Not bad. Digital learning, virtual learning. We can still get it done. We can still get our math on. That's fantastic. Thank you, everyone. Have a great day.